My Algebra 1 course. This is Understanding Functions in Algebra 1, which means we're reviewing about functions. So we're going to be exploring the concept of functions, definitions, types, and real-world applications. A function is a relationship between a set of inputs and outputs where each input corresponds to exactly one output. For example, in the function f(x) equals 2x plus 3, each value of x results in a unique value of x and x in parentheses. Functions are critical in algebra as they model relationships, can represent equations graphically, and help in solving problems systematically. Understanding functions sets the foundation for higher level mathematics and real life applications. So now we're transitioning to core concepts. So, domain versus range. Domain consists of all possible input values, which is the x values, for which the function is defined. For example, in f(x) equals the square root of x, the domain is x is greater than or equal to 0. Range includes all possible output values, which is the y values. For the same function, the range is also y is greater than or equal to 0. Understanding domain and range is critical for graphing functions properly and analyzing their behavior. The types of functions. So now we're getting to the good stuff. So, linear functions create straight lines using the equation y equals mx plus b, where m is the slope. Because, well, what I call y equals mx plus b, this is also called slope-intercept form. Okay. I know I have terrible writing when it comes to drawing online. So, quadratic functions produce parabolas defined by y equals ax squared plus bx equals plus c. Absolute value functions yield V-shaped graphs and are represented as y equals the absolute value of x, displaying non-negative outputs. Core principles of functions. So, let's summarize essential concepts of functions in Algebra 1. So, number 1, every function has an input and an output. 2, domain and range are the key characteristics. 3, functions can be linear, quadratic, or absolute value. Or 4, graphs visually represent the relationship of functions. So, visualizing functions. Graphs can illustrate the nature of different functions and their behaviors. For instance, linear functions maintain a constant slope, where quadratic functions curve, and absolute value functions reflect on the x-axis. These visual representations can aid in understanding complex mathematical C. Yeah, this picture was a photo by Tara Winstead on Pexels. It looks like a hexagon or 3D shape. Exploring absolute value functions. So, absolute value functions are defined by the distance from 0, representing as y equals the absolute value of x. They are crucial because they model real-world scenarios, which magnitude is essential, such as temperature differences. The graph of the absolute value function always forms a V shape indicating values that are n, which is, I do not know what that even means. So, here is an example of absolute graph. So, okay. This picture was by Sergey Meshkov on Pexels. Real-world applications. Functions are applied in various fields such as physics, economics, and engineering. For instance, population growth can be modeled using exponential functions, while profit and revenue might be expressed through linear functions. These applications help us comprehend and predict trends with the mathematical relationships. So, for example, the 7th billion person was born on October 31st, 2011 in the Philippines. Then 11 years later, there are 8 billion people. The 8 billion person was based on in the Philippines too. So, we could use exponential functions because we could use population all around the globe. Key insights into functions. So here is a quote. Understanding functions enhances problem-solving skills and analytic thinking. As mathematician John von Neumann stated, the science of mathematics is a model of the science of ideas. Grasping functions allows individuals to interpret complex data and apply it effectively in various situations, and essential for future learning and application. So, domain and range examples. So, consider the function f and x in parentheses equals 3x minus 5, where the domain is all real numbers. In contrast, f and x in parentheses is equal to 1 over x has a domain of all real numbers except x equals 0, showcasing the need to consider restrictions. Example 1. Okay, so these are all the examples. Summarizing function concepts. So, understanding functions involves recognizing characteristics such as domain and range, types of functions, and real-world applications. Functions are integral tools that aid in problem-solving and analysis, making them a fundamental part of Algebra 1. So I wonder what we're going to be learning about next. Because we have been through functions. I will work on chapters 1 and 2 during the summer, but number 4 is going to be writing equations and functions. Next steps in learning. So knowing functions opens the door to advanced topics like calculus and data analysis. Focus on practicing function problems, exploring transformation effects, and understanding function compositions. So here are 4 keys. So practice with different types of functions. Explore domain and range restrictions. Visualize functions using graphs and apply functions in real-life scenarios. So, thank you for your attention. We hope you have gained valuable insights into functions in Algebra 1. Keep exploring and practicing. And also, thanks for watching this video if you are an Algebra 1 or if you are an Algebra 1 parent or teacher. Yeah, so this is most likely going to be my last Algebra 1 video of 2025. So, Merry Christmas and a Happy New Year.